Yeah. Good evening, all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible?
Clear and visible.
Right? Is my voice clear to all? Can anyone please confirm once? Full to all. Okay. So in the demo session, right? We had a demo session last week, right? In that we discussed PySpark. What is Apache Spark? Let us have a quick review what we have discussed. Apache Spark. Why PySpark is required? Need for PySpark and Python like Spark, Python, and Scala and PySpark features and real life usage of PySpark and the current PySpark job market. Yes. Evolution of Spark, right? It was developed in the year 2009. Spark was introduced in the year 2009 by the personality who introduced Spark was Matej Zaharia in AMP Lab Berkeley. And Spark was open sourced in the year 2010. It was made open sourced in the year 2010, right? And Spark was donated. Spark was donated to Apache Software Foundation in the year 2013, right? It was donated to Apache Software Foundation in the year 2013, right? So if I can define Apache Spark in 4 lines. So observe this. Spark, it's an open source distributed cluster computing framework with in-memory computing feature in parallel process style used for large-scale data processing. This is used for large-scale data processing, right? Yes. So I can say it's a general engine, right? The Apache Spark is a general engine for big data analysis, for processing, and for computation, right? In-memory computation, the main feature what we see here is in-memory computation means here data gets loaded into RAM and data gets processed within the RAM. So the storing and processing both happening within the RAM level, memory level. So data is divided into partition. The data set will be divided into multiple partitions that are distributed across multiple RAMs of multiple worker nodes and are processed parallelly. So any data set of huge volume divided into smaller parts called partitions. That partitions are distributed across multiple worker nodes and are processed parallelly. So I was saying it's a general engine. Spark is a general engine, right? For big data analysis, processing, and computation, right? Yes. And why PySpark? Why PySpark means it is the Python API, right? To use Spark. PySpark is an Python API. The Python package, I can say, right? Which is used for Spark. It is the lightning fast technology, right? PySpark is the lightning fast technology, which is designed for fast computation. So one of the important demanding tool among the data engineers, right? For this fast computation and work with bigger data sets. And PySpark, it is used for distributed SQL, right? And for creating data pipelines. So it's a PySpark is a data flow language. So we have got a sequence collection of pipes. One pipe output will be the input to the next pipe. Ingesting data into database, running machine learning algorithms, working with graph algorithms, working with the data streams, streaming data, right? So PySpark, Spark with Scala, and if you normally say Spark means by default implemented using Scala. Whenever you say PySpark means implementation in Python. So yes, need for PySpark, right? So here if you see, generally why we go for PySpark means today industry expecting the processing at a very high rate of speed, right? So whatever data is getting generated, anything through offline or through online, right? So this data will be containing many different types of patterns, unknown corrections, what is the market trends, preferences, user preferences, other useful business informations. So we need to extract that valuable information from this whatever data is provided. So we require some efficient tools for performing this, right? So already we have got many tools, but much more speeder and faster, right? So for that, big data is one of these. Big data PySpark is one of the solution for it. So combining Python and Spark, combining Python and Spark is the very efficient, right, for the world of big data. So that's why Apache Spark community. So Apache Spark community has came up with this PySpark Python API for using Spark. And see Python and Scala. So Spark can be implemented using Python and Scala, which is mostly preferred, right? Yes, I'll come back. Yes, Atul Anand, right? I'll come back to your queries at the end of the session. Yes, I'll be giving time for it. So yes. So difference between Python and Scala. Scala is one more language. See, two languages where Spark can be implemented using 4 languages. But mostly used languages are Python and Scala. By default, Spark built using Scala language, but today like the Python is mostly preferred. So it's dynamic. Python is dynamic typed. Yes, Scala is statistically typed. Means statically typed. Means if you're assigning a float to x, float variable created dynamically. If you're assigning 10 to x, integer variable created dynamically. If you're assigning a list variable created based upon what value is assigned, the variables created dynamically. Python has huge community. It has got huge community, 89,300 modules for different environments Python is providing. Scala community is smaller. See, yes, Aditya Kumar, right? Spark is an execution model used meant for processing. It can be implemented using Scala language or Python language. So in this course, we are going to discuss Spark with Python implementation. But generally, this Python and Scala, both languages are mostly preferred. Previously, Scala was preferred a lot. Now, currently, like Python is mostly preferred, right? So Python is one advantage of Scala over Python is Scala is 10 times faster than Python. Scala language, Python is slower than Scala. That's the only thing. Remaining everything, if you see community-wise, huge community, powerful libraries it has got for machine learning, graph algorithms. But Scala is little weaker as compared with Python. Coding-wise, length-wise, complexity-wise, if you check, right, Python implementation will be simpler and easier, and also, and apart, leave that coding-wise, but powerful libraries Python has got, right, for especially for this graph machine learning and for streaming, right? So there was one more product. There was one more product, right? Apache Software Foundation. That is, it has introduced was Flink. Flink was another product which was introduced by Apache Software Foundation. But Flink was dominating Spark in the initial versions, but Spark was weaker in data analytics. You see, Spark was weaker in data analytics, right? Means machine learning for all this. It has got weaker libraries in the initial versions like 1.6. So Flink was dominating, Spark was weaker than Flink. But from Spark 1.61, by introducing the Spark 1.6 version onwards, so Spark was equal to Flink, but from Spark 2 version onwards, it totally dominated Flink, right? So the Spark and Flink is also another product which is the same purpose, the objective. The purpose and objective is same like Spark, only the Flink. And real life usage of PySpark, right? real life usage of PySpark, right? Yes. In the commercial sector, right, and PySpark is mostly preferred today, right? So for real-time processing, today PySpark is mostly preferred for real-time processing. Then and there, for detecting any fraud, if any fraud is happening, right, immediately then and there immediately saying that fraud is happening. Bank and other financial fields are using Spark for retrieving customers' social media profiles and to extract useful insights which can help them in taking the right decisions, right? And even in credit risk assessment, in fraud detections, and in healthcare, right, for prediction and for analyzing the patient's records for the previous history and previous reports, and saying that which patient is mostly going to face the issue, right? Even after being discharged from the clinic. And entertainment industry also, right? It is going towards the online streaming. So entertainment industry moving towards online streaming, right? The most popular online stream, Netflix, using Apache Spark, right? So it uses nearly 450 billion events per day, right? It is going to stream 450 billion events per day for trading and e-commerce, right? And e-commerce websites, especially like Flipkart, Amazon, all this, they use Apache Spark for advertising and for recommendations. Generally, you should have seen recommendations. Even in machine learning, you can see recommender systems are available, right? User-based recommendations, item-based recommendations, right? Those kind of means a person purchasing a product, a mobile phone. So also purchasing some other product. So recommending, right? So most of the people who purchase this product also purchasing this product, they are recommending. Just like YouTube videos, right? Today, if you see some kind of YouTube videos, tomorrow it is going to recommend the same categories of videos. That kind of recommendations, right? Means advertising. So the Apache Spark is used for advertising, right? Within this e-commerce sites like Flipkart, Amazon, right? To enhance the customer experience and the overall performance. And even tourism industry, in giving some advices to many travelers by comparing the other tourism websites. So I was saying, right, Spark can be coded with Scala, Python. These are the mostly preferred languages, but by default, Spark was built by using Scala language. But previously, Scala was used most. Now Python is mostly preferred, right? Execution generations, if we talk, previously if we talk about Hadoop, MapReduce execution, we see like MapReduce execution, Sage, Spark. So MapReduce, okay, MapReduce execution, it was well designed, but it got outdated when Spark was introduced. This MapReduce got outdated. And the difference between Sage and Spark, both follows DAG model, directed acyclic graph. Sage doesn't support in-memory. Sage is a technology which doesn't support in-memory, but Spark has got in-memory computation. So Spark has got high speed as compared to Sage, because in-memory computation always will be the fast processing, fast computation, right? Other in-memory computing systems, right? Like we have got SAP HANA, right? HANA and Spark, if you talk about, both follows in-memory, but HANA is not distributed, but Spark is distributed RAM. Means so data is distributed across multiple RAMs of multiple systems, right? For huge storage, generally we go for Hadoop. For fast processing, going for PySpark. Combinedly, both Hadoop and PySpark when both store and process data. And PySpark is mainly designed for right, batch applications. Batch applications means user non-interactive applications.
Sir,
Online,
PySpark alone cannot be used. it should be used with Hadoop, right?
So PySpark is for processing, right? So Hadoop file system is there, right? Hadoop distributed file system. But they will be storing it, and from there PySpark takes the input and
Yeah.
process.
So my question is that can we use PySpark alone, or we should use PySpark plus Hadoop?
So totally this Spark, right? Runs on the Hadoop yarn cluster. So this Spark, it is going to run on Hadoop yarn cluster.
Okay.
Execution, everything happens within the Hadoop yarn cluster.
Okay.
So yes,
So Yarn is a kind of OS kind of thing.
yet another resource negotiator, we say, right? So how this is a cluster, right? And how this processing is going to happen within this cluster. It's not kind of OS, but it's a cluster, right? Distributed cluster.
Yeah. Cluster means number of systems.
Yes, say here, 1 second. So here in the case of Hadoop, master and slave architecture is followed. Master and slave, single master and multiple slaves. This master node, and within that we have got master. These are slaves. Master and slave architecture. So here already we have got many services available within the master, within the slave level. What? Within the master and slave level, already we have got some services available, right? So yes, in Spark, right? Data object, it will be divided into multiple partitions. Yes. So once this Hadoop yarn cluster is maintained, right? So is whenever the Spark data set divided into partitions, it will be stored in the RAMs of each system. Each partition will be stored in the RAM of each system. This is going to be distributed across multiple RAMs of multiple worker nodes, we say, right? And whatever
Sir, sorry, can you please repeat this?
So any data set, data file, right? A data set will be divided into partitions, into partitions, right? It will be divided into partitions, and these partitions are distributed across multiple RAMs of multiple slave nodes. Here, so distributed execution is going to happen, and data is going to be distributed across multiple, and within the memory level getting stored, within the memory level processing happening. Yes, in the case of Hadoop, right, data storing within the disk level, but here in Spark, in the memory level storage and process within the memory level. Once the job execution is completed, everything will be cleared from the RAMs, so that the next you can just trigger the next flow, data flow, or the next job can be performed. So once the job is completed, total RAM will be cleared, so that the next job or the next data flow can be triggered. Again, it will be distributed, again executes. Once the execution is finished, and it clears the RAM. In this way, it goes. And the final result will be stored. If you want to store in HDFS, right? Hadoop distributed file system, right? Yes. Okay.
So all the data will be stored in the Hadoop system, right? HDFS.
Yes, yes. Hadoop distributed file system. So if anyone doesn't have knowledge in HDFS, right? Hadoop distributed file system, right? You need to have this knowledge. If it doesn't have, just I'll forward that video in notes for this. Before I go with the practicals of this, right? I'll just forward you some videos of HDFS and notes of this. You can just go through if anyone doesn't have knowledge on this Hadoop HDFS. Right? Okay. So PySpark is mainly defined for batch applications. Iterative algorithms. Iterative algorithms means most of these ML algorithms are iterative in nature. Iterative means again and again we are going to apply the technique on the same input data. So until the error becomes zero, whenever we perform, right? Whenever you are applying, we're working with this. First, whenever we apply this techniques, we will get some error. So we repeatedly keep on applying until the error becomes zero. And interactive queries, SQL queries. Using PySpark, we have got concept of data frames. Within the data frames, we can perform some kind of SQL kind of querying, right? And streaming data streams, working with streaming data in integration with Kafka, right? So mainly for batch applications, millions and trillions of records, and user non-interactive applications. So it's mainly designed for batch applications, for iterative algorithms, for interactive queries, SQL queries, and for streaming. Yes. So MapReduce, in Hadoop, we have got MapReduce execution model. The main drawback with MapReduce is transformations cannot be reused. Means already if you have executed any transformations, the output of it cannot be reused. But in Spark, if you have executed some transformations, the output you can reuse in another transformations, right? Bad for iterative algorithms. MapReduce is bad for iterative algorithms. Means most of these ML algorithms are iterative algorithms, but this MapReduce is bad for this. Not a flexible parallel process. MapReduce, mapper phase, reducer phase. Actually, they are meant for parallel processing. MapReduce is meant for parallel processing. First mapper phase execution, next reducer phase execution. But both mapper and reducer can't be executed parallelly. But they are meant for parallel processing. But first mapper output is taken as input by the reducer. So one after the other. It's not a flexible parallel process. And slow processing. You know what? MapReduce has got slow processing. And there is another processing component like Apache Pig. Spark and Apache Pig means both are data flow languages only. But in Pig, the entire data flow is converted into one MapReduce job. But again, MapReduce, we have discussed that it has got drawbacks. So in Pig also, the entire data flow is converted into MapReduce and MapReduce job executes. Right. Spark features and advantages, right? Now from the discussions what we had, in-memory computations, which Tej technology doesn't. Distributed execution, which HANA doesn't have. Flexible parallel process, where MR has got the drawback. Transformations can be reused here in Spark. Good for iterative algorithms. Very high-speed processing you see in multi-language support like Python, Scala, Java, and our language. In multiple languages, you can implement this Spark. Support advanced analytics. Spark supports advanced analytics like machine learning, graph, and data streams. Lazy evaluated. And a persistence feature, right? Yes. Spark persistence feature. Persistence feature means yes, if anything is getting persisted, then that output can be used by the other flows. If not persisted, it can't be used. More discussion of this persistence I'll be discussing, right, in today's session. Powerful fault tolerant model. Spark has got powerful fault tolerant model. Yes. So, and if you want to see the speed, right? Yes. Yahoo has taken a table of 100 TB consisting of 1024 columns. Task sorting based on 16 columns, right? So time taken by the different databases. Oracle has taken 3.5 days. MySQL has taken 6 days. Teradata has taken 4.5 hours. Netija another See, Teradata is a specialized database, right? Used for data warehouse purpose. That's just taken hours of time. Netija, another specialized database for data warehouse purpose, taken 3 hours. But finally, Hadoop has taken 3.2 minutes, where these databases have taken days, these have taken hours, but Hadoop has taken in minutes. Hadoop, right? Hadoop MapReduce. But Spark 100 times faster than Hadoop. Imagine, right? Already Hadoop has got very fast speed, right? But compared to that, Spark is 100 times faster than, right? Motivation towards Spark. Motivation towards Spark, right? Yes. Here, Spark. Observe this motivation towards Spark. Spark sorted 100 TB data. 100 TB data using 206 nodes. In 23 minutes. Spark sorted 100 TB data using 206 nodes in 23 minutes. Previous world record was 72 minutes. Set by previous world record was 72 minutes set by Hadoop. Hadoop MR cluster. Hadoop MR cluster. Even by using 2100 node systems. Here it has used only 206 systems nodes. But even by using 2100 systems, right, it has taken 72 minutes. So if we talk like in memory level, right? If you talk with memory 100 times faster than MapReduce. 100 times faster than MapReduce. In disk, talk about in disk, right? 10 times. Both if you are 10 times faster. 10 times faster than MemBar. Right? Yes. So, okay, that is an introduction to that. But now, entering into this Spark data objects, right? Spark, once again, I say Spark is not a language, right? It's a execution model. It's a execution framework, right? Implemented by using multiple languages, like by default built using Scala, right? Now can be implemented in multiple programming languages. So today, like even Python is mostly preferred or used. So now RDDs. RDD. The full form of this, you need to know about this. Resilient distributed data sets. Resilient distributed data sets. See, Spark data objects. Spark data objects, right? Yes. Are called as RTDs. Spark data objects we call it as RTDs. So how these RTDs are computed, how they are loaded, how they are computed, we'll be discussing, right? RTDs are subdivided. RTDs are subdivided into partitions. RTDs are subdivided into partitions. These partitions are distributed. These partitions are distributed across multiple RAMs. Of multiple worker nodes, slave nodes, worker nodes. Here the advantage. Here the advantage, right? Yes. What is the advantage? Huge data sets. Huge data sets means we say RTD can be loaded. Here the advantage, huge data sets RTD.
Sir, one doubt, sir. Like, these partitions are distributed across multiple RAMs of multiple workers.
Yes.
These multiple RAMs means are these multiple systems? Like, I did
Yes.
not get that.
Worker nodes. Nodes means CPUs.
Like these things will be executed in the cloud or something like that.
Yes. So you can execute within this on premises, on cloud premises, you can execute this. You can create a cluster, right? When on premises means you can create a cluster, right? And on cloud premises also, you can just execute this. Even Spark can execute on AWS, right? Cluster, distributed clusters. Huge data sets also can be loaded. So here RTD, you need to know much on this RTD programming style. RTD programming style. Data flow. RTD programming style is data flow. Data flow, right? Data flow indicates is a sequence collection of, it's a sequence collection of, data flow means sequence collection of pipes. Sequence collection of pipes. Pipes means RTDs, I said. Sequence collection of RTDs or sequence collection of pipes. A pipe is any data operation. Is any data operation. Is any data operation. The operation can be loading the data. Whenever you load data, RTD gets created. Transforming data. See, data flow is a sequence collection of pipes. A pipe is any data operation. Loading data, transforming data. Merging data. Filtering data. Sorting data. Etc. So at each data operation, right, in a pipe is any data operation. So transformation will be done to the data, or merging will be done, to filtering will be done, or sorting will be done, right?
These pipes are batch or stream or both.
What is it?
The pipes, whatever you have mentioned.
So in
The
Spark, in Spark, right? So batch, and here mainly Spark is mainly used for micro batching. Micro batching, it means if you want for streaming side, right? Micro batching, we say very quick updates if you want. So everything Spark is meant for Spark for batch processing. Both streaming data and this both it can process both, right?
Sir, can't we do the data processing part using the Spark, PySpark?
PySpark only.
Yes, sir.
This means whatever Spark is an execution model, means 1 second. Spark.
Actually, the confusion lies like you are using sometime it is Spark, sometime it is PySpark. That was a confusion.
See, the Spark related whatever that is there will be common. Spark has got many built-in functionalities, what all will be same. But okay, Spark, okay, but coding in Python or coding in Scala. So how you will define if you want to, okay, Spark related functionalities will be same. If you got some 100 functions are there, all these 100 functions will be same in Python and Scala. What is Spark related functions? But the language or coding is going to differ here.
For clarification, like for example, what I understood is like we have some kind of sorting, like whether it is ascending or descending is an example. So that can be written in any kind of programming language like Python, Java, or C++. Is that true, sir? Something like that. Spark, you have some kind of functionalities. So in order to prove how those functionalities or how to use those functionalities, we'll be using either Python or Scala.
For example, very small example. You want to develop for example, I'll take if you want to develop a web application, to create a web application, you can go with Java language, with Python language. You can create that application using Java or using Python. The web application, whatever the output will be the same. Output will be same, but programming code will be changing, right? Functionalities will be changing. But here also Spark, what all the Spark functionalities will be common. If say 100 functions given by Spark, that 100 function will be common in Python and in Scala. But the coding is going to change. Means in Python, if you are defining a variable, directly x equal to 10. In Scala, we will say var x equal to 10. This kind of coding will be changing, defining variables, defining functions, defining collections, these things. But Spark related functionalities will be common, right? In all the languages. What all the Spark related inbuilt functions, what are provided will be common. So yes, whatever, okay. Yes. Spark data objects are called as RTDs. RTDs are subdivided into partitions. These partitions distributed across maps. That okay. So if you get confused, then just say PySpark here. PySpark data objects RTDs. Only here I use, right? PySpark data objects. Okay. So, okay, what about this, right? Spark, we say, can be executed by using Python Scala. Spark with Python, if you are implementing, we call like PySpark. Spark with Scala implementation, right? So here, if you say in Spark, data objects we call like RTD. RTD subdivided into partitions. Partitions, they are distributed across multiple RAMs of multiple worker nodes. And here data flow is sequence collection of pipes. So RTD programming style is data flow. Data flow is collection of pipes. A pipe is any data operation. A pipe is any data operation, right? Data operation can be loading, you can transform, merging, filtering, sorting. Means data flow means, okay, first I loaded the data. Next, I perform some filtering operations. Filtering operations, the output of the filtering operation will be the input to the next flow. Next, I perform some merging, the merging output. So in this way, the output of one will be the input to the next one. Okay. In Spark, data flow is executed. This is important. In Spark, data flow is executed in sequence. Data flow is executed in sequence. That is RTD by RTD. In Spark, data flow is executed in sequence. That is RTD by RTD, one after the another. Why? Why? RTD by RTD. The first RTD output will be the input to the second RTD, right? So both cannot execute in parallel.
Executes in RAM only.
Sir,
So
any kind of like execution kind of a thing that can be shown now?
yes, yes. I'll show you
Yeah,
some.
this is lazy operation, right?
Yeah, lazy evolution. In Spark, data flow is executed in, that is RTD by RTD, one after the another, one after the. I'll show you some examples, right? Some flows I'll show you now. How this data flows, how this Spark RTDs are computed. Now I'll be showing some diagrams. I'll just draw some diagrams and show you how these are computed. So data flow is executed in sequence RTD by RTD, one after the another, because the output of one RTD will be the input to the next RTD. Yes. Data flow is executed, that is RTD by RTD, one after the another. One after the another, RTD by RTD, one after the another, with in-memory computation, with in-memory computation, and persistence feature. Okay. One after the with in-memory computation and persistence feature, right? What is persistence feature means? if any output, if you are persisting, that will remain in the RAM, and any other flow which requires this output can be reused. So this persistence, this in-memory computation, RTD computation, just I'll be discussing some examples now. So here you may ask a query. When data flow is Spark is meant for parallel processing. When the data flow is executed in sequence, that is RTD by RTD, where we see the parallel processing, where we are seeing the parallel processing means, observe. If a RTD has got 30 partitions, if a RTD has got 30 partitions, then all these 30 partitions can execute parallelly, can execute in parallel. All these 30 partitions can execute in parallel. So just observe this diagram, right?
Sir, what is distributed processing and what is parallel processing? Both are same, right?
Yes. Okay. So
Sir?
here, yes.
So what is distributed processing and what is parallel processing?
So here data is distributed, right, across multiple RAMs. Data is distributed across multiple RAMs. And all those with some business logic, all they are going to get executed parallelly. All those are going to execute parallelly. Means parallelly they are processed and they are going to give the output. Means what you are able to see there, if data is divided into 10 partitions, 10 partitions are distributed, 10 partitions are distributed across 10 RAMs of 10 systems, and they are processed parallelly. Yes, that is what parallel processing means. Here also, here if you say distributed and processed parallelly. Here if you see, this is the RTD. It is distributed, it is divided into multiple partitions. P1 is one partition in RAM, P2 partition, P3 partition. In this way, it is divided into P30 partitions. So this RTD is divided in 30 partition. First partition system 1 in system 2, system 3. It's in the RAMs, within the RAMs. Okay. In system 30 means all these partitions are executed parallelly by 30 systems. Means this output, whatever you are going to get from this output is given, the output of this is given as input to the RTD2. If this is RTD1, if this is the RTD1, the RTD1 partitions are divided into multiple partitions stored across multiple systems and processed. The output is taken as input by the RTD2. Means this what I am RTD1 and RTD2, both RTD1 and RTD2, both RTD1 to both are not executed parallelly until RTD1 execution finished and RTD1 output is given as input to RTD2. Now RTD2 will be computed.
Sir,
Sir,
is
one
it
doubt.
like the file, the input file is being divided into partitions, right? P1, P2, P3.
Yes.
Sir,
Yes.
if the data, whatever the data means input file is divided into partition, suppose we are given a large table and we are doing some ranking here. And if the data is divided, then how we can do the ranking? It should be in all the processing should be one, right? And if we are doing the partition and then doing the processing in S1, S2, then how the ranking will be done? Are you getting my thing right?
Yes, yes.
Yeah.
So, okay. So first in this P1, whatever the partitions are there, you will be getting the ranks here. You will be getting the ranks here. So
Yeah,
P2
but it
part
should
in
it should
P2,
compared with all the things, right? It should compare with the first and 100 ranks. And suppose there are 100 tables are there, means 100 row are there. So it should be and whatever I understand that the 100 rows are divided into P1, P2, P3 like partitions, means 10, 10, 10, 10, means 10 partitions. So how we can get that? Because at last we need 1 to 100 rank, right? And if we are dividing the total 100 rows into 10, 10, 10, 10, then how we can do the ranking here? If we are doing processing like this?
so okay, ranking kind of operation, right?
Yes.
For multiple partitions, ranking. So yes. So one more node. See here, one more system, right? So the output of this everything, the output of all this, right? So for example, generally, this is an RTD. Okay, P1, P2, P3, P30. So here, for example, assume that, okay, rank you forget. First you say, I want to compute the sum. I want to know what is the total revenue generated. Here, some 40 transactions data. Here some 40 transactions. Here some 70 transactions. In this way, I want the total revenue generated. I want, right? So lakhs of records are there. So first, what is happening here? You will get the sum of this. You will get the sum of this. You will get the sum of this. Sum of this. You will get the final sum, right? So all this will be collected. The sum 1 here, sum 2, sum 3, sum 4. So in another node, all this sum 1 plus sum 2 plus sum 3, whatever is there, will be added and final output will be collected. Sum 1, sum 1, sum 3, sum 1, all this, right? Yes. In another particular node, so all these sums will be whatever the sum 1 of this, sum 2, sum 3, sum 4, sum 5.
Yeah, this is
Yes.
work for the sum operation, right? But if the ranking operation, how it will perform?
Ranking operation also in the same manner. Ranking operation also in the same manner. See, if you want to see the output of this, you can see that output of this partition and you can see the ranks of this. For this partition wise, if you want to see also, you can see, right? Separately. The ranks of this separate part files will be created. But finally, I want to see within a single, right? You can see all the ranks. So in Spark, you can control the parallel processing into how many partitions you want also. You can control that. I want into this many partitions. So while loading the data, we will specifying the number of partitions. Yes. How many partitions? Those many files you will be getting, right? Later, we have got other techniques to measure all those partitions. Fine. If or see internally everything it is going to get computed, the final output will be collected by the next RTD. So here internally data will be partitioned, data will be processed internally, everything happens internally. The next RTD collects that output. Or finally, if you want to just display the output, you can display it. So we no need to do about all those things, how it is and how it is processed internally. So it just computes and gives the output. Means this is going to get processed parallelly. If you RTD, okay, just I'll show you some examples, right? Just observe this. If you want to see, if you want to know the RTD computations, right? You're asking, it's just try to know first so that you will get all the clarity on this RTD computations. For example, think that this is an RTD. R1 is an RTD. See, I'm writing if R1 output is taken by R2. R2 output is taken by R3. R3, here I'm taking it as R4, R5, R6, R7, R8, R9. In this way, you have got that. R1 output is taken by R2, R2 output is taken as input by R3. From R3 output is taken by these three things, R4, R5, and R6. Assume this is flow 1. This is flow 1. Flow 2, just observe, this is the flow 2. Up to from here to here, it goes like this. Flow 2.
Sir, this is the same persist example, right?
Yes. This is flow 3. Here you can see how these RTDs are computed and also the persistence, how an RTD can be persisted. Yes. Flow 1, R1, R2, R3, R4. Flow 2, R1, R2, R3, R5, R8. Flow 3, right? R1, R2, R3, R6, R9. So this is 3 flows are there. So here I said Spark has got persistence feature, and one more feature I said transformations can be reused. Those two you can see, and also RTD computations. 3 things you can observe. One is persistence feature, one is transformations reusing, third is the RTD computations. If I want to, if I want to execute this, lazy evolution. Spark is lazy evoluted. Spark is lazy evoluted, or lazy evolution you say. Spark follows lazy evolution. Lazy evolution means active evolution. Lazy evolution means once to execute this entire data flow, if you want to execute, perform some action. You have got some inbuilt actions are there. If you perform that action only, this will execute. Otherwise, this flow won't execute. The last RTD, generally on the last RTD, you will perform action so that the execution starts from the root R1 to R4, it executes and gives the output. If action is performed only, the flow executes. That's what we call lazy evoluted. Just like functions. If you make a function call, then only function executes. If no function call, then function never executes. That is lazy evolution. So here also, if I want to make a executing first flow, executing the first flow. Executing the first flow, right? So whenever you say R4 dot action, whenever you say R4 dot action, right? Not so R4, R7 is the last R7, right? R7 dot action. R7 dot action. If you say R7 dot action, then from R1, the flow starts from R1 to R2 to R3 to R4 to R7. Okay, the flow starts from R1 to R7. So the output of it will be given to this. The output of this will be given as input to this. Once R2 is loaded, when R2 is loaded and computed, R1 gets removed from the RAM. R2 output, once R3 is collected and computed, R2 gets removed from the RAM. See, all these 5 RTDs at a time, they cannot be loaded into RAM. RAMs cannot accommodate these many RTDs, right? When R4 is loaded, R3 is going to get removed from the RAM automatically. When R7 is loaded, R4 gets removed from the RAM. Once R7 output is collected, R7 also removed from the RAM. So what is in the RAM now? No RTD in the RAM. So you can execute the second flow, executing the second flow. For executing the second flow, I need to perform action on R8. If you perform action only, the flow executes from the root. Here also the same thing it follows. R1, R2, R3, R5, R8. When this is ready and computed, first R1, all partitions will be loaded into RAM. It computes, output will be given. Whatever the output, the final, whatever the sum or rank or whatever you give, the output, the final output will be taken by R2. Yes. Once R2 is loaded and computed, R1 is going to get removed. R2, now R2. So doesn't mean that R1 and R2 sides will be the same. No. If you're filtering data from R1, only Hyderabad records, particular city records, means if there are 1 lakh, in that Hyderabad records are only like 500. This out of 1 lakh, nearly 95% got removed, right? It's only 5% will be present in R2. On that R2, again, if you perform any logic, R3 gets created. So once R3 is loaded and computed, R2 gets removed. Once R5 is loaded and computed, once R5 loaded and computed, R3 gets removed from the RAM. So when R8, once the output is collected, right? Total everything, this R8 also got removed. So if you see the last flow also, R9, if you perform that action, then only it will execute from, means data flow execution, I'm saying, how the RTD's executions, right? R6, R9. When this is loaded, this gets removed. When this is loaded and completed, this gets removed. Once this output is collected, this also gets removed. Now, after executing this flow, no RTD is present within the RAM. Now you can trigger any other flow. But here, the drawback, what you observe here, first 3 steps are common in all the flows. First 3 steps are common all the flow. So I want to perform some kind of aggregations. For example, from R3, max aggregation I want, min aggregation I want, average, sum aggregation I want on the from the R3 data, on R3 data. So here, if you observe in all these flows, flow is re-executing from the beginning. flow is re-executing from the beginning. So to avoid this, flow is re-executing from the beginning. So to avoid this, we need to identify the RTD. We need to identify the RTD whose output is used by multiple flows. Whose output is used by means R3 and persist it. Persist it. How will you persist? By saying R3 dot persist. It gets persisted. Once it is persisted, right? Now what is that? So R3 remains in the RAM. See now the flow, observe this, the flow will be like this. Once it is persisted, right? First, now see after persisting, I'm taking this once again, see this R1, R2, R3 is persisted, R4, R5, R6, R7, R8, R9. When it is persisted, right? Whenever you say the first flow, flow one, once you say R7 dot action. So first flow, there is R1, R2, R3, R4. You need to understand clearly when a RTD is going to get persisted. When an RTD is going to get persisted, understand? First R1 in its partitions loaded, computed, output you got is taken as input by R2. Once R2, okay, loaded and R2 is computed, R1 gets removed from the RAM. Now R2 is loaded, computed, and output is collected by R3, and R3 computed, R2 gets removed. Now when R3 is loaded, into the RAM, it gets persisted. Persisted means making that RTD available in the RAM permanently. Persisted means making this RTD available in the RAM permanently, even though the next RTD is ready, this R3 won't be removed from the RAM. When R7 is ready, R4 gets removed. Once the output is collected, R7 is removed. Now, what is present in the RAM? Yes, try to answer everyone. What is in the RAM now? Hello?
Nothing is in the
R3 in the RAM.
R3.
R3 is present in the
after
RAM.
execution, nothing is there, right?
R3 is present in the RAM. When our output is collected, R7 gets removed. But what do you mean by persist? What do you mean by persist, right? Means R3 should remain permanently. Even though next R4 is ready and computed, R3 won't be deleted. Why you are making R3 to persist means observe this flow 2. For flow 2, what is that I need to say? R8 dot action. R8 dot action means for R8 who should give input to R8? For this R8 who has to give the input?
5.
R8 input is
R5.
R5. For R5 who has to give the input?
R3.
R3, right? R3 in the RAM. R3 present in the RAM, right? R3 is present in the RAM. No need to go again search for that R3 input is R2 like that. Your flow is like this. R3 to R5, R5 to R8. Understand? Means directly R3 is giving the output directly to that. No need to execute from the starting here. Why? Because when R3 is already available, collect this R3 output and compute R5 and R8. Once R5 is ready, R3 won't be removed. When R8 is, R5 gets removed. Once the output is collected, R8 gets removed from the RAM. Now, what is present in the RAM after the second flow? Everyone, I want the sessions to be more interactive.
R3 only.
R3 in RAM. Once the second flow executed also, R3 remains in the RAM. Means one persisted RTDs will compulsory remains in the RAM. Now the advantage of this is in flow 3 also, right? Directly no need to execute from the starting. If you want to execute the flow 3, on which one I need to perform action? On the last R9. R9 dot action. So from where R9 has to get the input from? R9 input is R9 input is R6. R6 not present in the RAM. R6 input is R6 input.
R3.
R3 is present in the RAM, right? Now the flow will be what? R3, R6, R9, R3, R6, and R9. Once R6 is ready, R3 won't be removed. Once R9 ready, this gets removed. Once the output is collected, this R9 gets removed, right? Yes, yes. Okay. Now in all the three flows, right, R3 remains in the RAM. R3 present in the RAM. So here, if you see a big data flow, if you see a very big data flow, the previously also I said, right, R1, R2, in this way, R40 is there, R40 is there. Means R1 40 RTDs, R40s, R50, R60, R70. Means the first 40 steps are common for all the three flows. This is flow 1, this is flow 2, and this is flow 3. Three flows are there, right? Here, three flows. So, yes, all the three flows, right? Flow 1, flow 2, and flow 3. In all the three flows, first 40 steps are common, right? First, this flow 1 has to be executed. If flow 1 executes only, this R4 can be persisted. During the flow after R39, once R4 is loaded, observe when a RTD get persisted, when a RTD is going to get persisted, when it first time gets loaded into the RAM after R39, when R40 is loaded, immediately it will be persisted. So once the flow 1 execution is finished, R40 is persisted. Flow 2, right? Flow 2, no need to execute from the starting. First 40 steps, R40 to R60, that's it. This is the flow. First 40 steps decreased, right, in flow 2. Means the transformation which was executed in flow 1 is reused by the flow 2, right? In flow 3 also, right? R40 available in the RAM to give the output to that R70, whatever it is. That means 40 steps decreased in flow 2 and 40 steps decreased in flow 3. Means in flow 1, the transformation which was executed, the output is reused. The output of that is reused by the flow 2, flow 3, other flows, right? Means understood here, transformations can be reused. So in R40, whatever means you perform filter operation on R40 or sort operation on R40 or any transformation operations on R40. Okay, you can apply because R40 available in the RAM. in all the above flows, right? Once the entire flows are complete, still R40 will remains in the RAM. R40 remains in the RAM. If not required, once all the execution finished, right? Once all the executions finished, if you doesn't want R40 within the RAM, forcefully unpersist R40 dot unpersist. Unpersist it. So that also gets removed from the RAM. That is one way of unpersisting. Second way is when the session is closed. When the session is closed. Or when server shutdowns. Three ways, right? When you unpersist it forcefully. When session is closed, it gets unpersist when server shutdowns, right? Three ways to unpersist an RTD. What are the two situations, right? So here I'll say two situations where RTD will be removed. Try to say me two situations where RTD will be removed from the RAM. From the previous example, right? Two situations where RTD will be removed from the RAM. First one. Whenever next RTD is ready, current RTD will be removed. Whenever next RTD is ready, erase current or previous RTD. Whenever next RTD is ready, previous RTD will be removed. Second situation, right? Second situation. When action is complete, when action or execution is completed, when action or execution is completed, then last RTD gets removed. Then last RTD gets removed. What are the three ways to unpersist an RTD? Unpersist an RTD. What are the three ways to unpersist an RTD? Yes. I'll come back to this, but before that, I'll come back to this three ways. What are the two ways to persist an RTD? Two ways to persist an RTD. Multiple queries questions right here. Two ways to persist an RTD. First one. RTD dot persist. If we say it gets persisted. Second way is RTD dot cache. You can say if you want to persist any RTD, you can say this or this. Difference between these two is, so here next persistence options are there. In memory, you can, in disk only if you want to persist, in memory only if you want to persist, in memory or disk, in anyone. If memory available, persist in memory, otherwise persist in disk, that option. Otherwise in memory only you persist, otherwise in disk you persist. Multiple options. This first one will support all those memory, disk and memory and disk. This is only for memory. Understand this? If memory, only if you want to persist in memory. In disk, if you want to persist in disk. In memory or disk, if memory available in memory, otherwise in disk. The three options supported by this. But this supports only the first one, only in memory. So 2 ways to persist in RTD. 2 situations where RTD will be removed from the RAM. 3 ways to unpersist in RTD. First one is forcefully unpersisting. Forcefully unpersisting by saying RTD dot unpersist. Forcefully unpersisting by saying RTD dot unpersist. Second way, when session is closed. When server shutdowns. Now, what is lazy evolution in Spark? What is lazy evolution in PySpark? What is lazy evolution in PySpark? Can anyone say what is lazy evolution in PySpark?
It's action on demand. It is action on demand, right?
Yes, exactly right. Executing the data flow on demand. Executing the data flow on demand. On demand by performing an action. I'll show you what are the different actions. Executing the data flow on demand by performing an action. It's called as lazy evolution. It's called as lazy evolution, right? Yes. So here you may get many, so you will get many queries here, right? In this computation. So I'll be forwarding you all these notes, whatever so whatever diagrams I have drawn, right? For that also I have got I have drawn diagrams, right, in Paint.
So will you be keeping the notes in the drive?
RTD computation. What all this? Executing flow 1, executing flow 2, executing flow 3. How they are getting loaded, right? This one. This will be
So the
in
notes
Paint.
and everything will be available in the drive only, right? The recording drive.
I'll be forwarding you, right? Yes.
Oh.
I'll be forwarding either through mail or through in WhatsApp.
Okay.
So coming back here, right? Many queries here. Different ways to unpersist in RTD, different ways to persist in RTD. What are the different persist options that I will be discussing? And what is lazy evolution in PySpark? How this RTD can, what different steps in RTD computations? And one more important thing is, you may ask, when the data is divided into multiple partitions and loaded across multiple RAMs of multiple systems, suddenly if a particular system goes down, suddenly if it fails, then how you are going to lose the data? That we call it like fault tolerance model in PySpark. Fault tolerance model in PySpark, right? So if anything goes down, that means now I'll just explain step by step of RTD computation. What are the steps? What are the rules involved in this RTD computation? And next, fault tolerance model in PySpark. I'll be discussing, right? In the tomorrow session, I'll be discussing those things. Fault tolerance model in PySpark and the RTD computation step by step, right? This and some more examples and different persistence features. So before we go with the practical part, we have got small discussions, right? Tomorrow session also, right? So you can see in that, okay, you can see in the chart, right? In the chart panel, the payment process and procedure is given in the chart. So the interested ones who want to continue with this, right, can go with this. Share the screenshot of the payment to that mail ID given, DURGASOFT online.
Sir, is there any concession for your old student?
And training, right? So this is the pardon?
Sir, is there any concession in fee for older student of your?
You did what?
I'm the older student of the Python. So is there any concession we'll get?
So that those things you need to discuss with that, right? About the technical things you can have a discussion, but about the financials you can see that mobile numbers given, right?
Yeah.
You can discuss and you can say the same thing if you are an old student, right? To
Yeah.
those. Okay. Fine. So PySpark introduction, Apache PySpark, need for PySpark features, web application sessions, parallelizing, repartition, broadcast variables, RTD computations, DAG. What do you mean by DAG? RTD computations, RTD persistence features, persistence options, PySpark core computation, fault tolerance model, creating Spark objects, increasing the number of partitions, aggregations over the data, groupings and aggregations, single grouping, multi-grouping, single aggregations, multiple aggregations, process of group by key, reduce by key, reduce various inbuilt transformations, inbuilt, what are the various actions and what are the various transformations one by one, right? So all these are the inbuilt and PySpark data frames. So mainly this is important data frame concepts, making the data structure, data frame, creating a table structure and various data frame APIs. What are the inbuilt features in the data frames? The APIs, right, one by one with working examples. And the SQL functions, if you want to perform pure SQL kind of querying. And also there are some PySpark provided aggregate functions, window functions, date functions, timestamp functions, JSON functions, and the inbuilt functions of PySpark. We don't need to write codes. We have got many inbuilt functions. All this will be discussing, right? All these functions and PySpark external sources. Yes, working with SQL statements, Spark and PySpark and Hive integration and MySQL integration, working with CSV, JSON transformations. Okay, all this. So yes, and deployment modes, local mode, cluster mode, PySpark applications, stages, tasks, drivers, executors, deploying Spark applications to cluster and performance tuning, PySpark streaming concepts, integration with Kafka and PySpark MLlib, right? Yes.
Sir, PySpark, what is the database for this PySpark, sir?
What is it?
What is the database we use?
So already, yes, drawbacks. So in Hadoop and PySpark, right? We won't use database because databases has got a lot of drawbacks. Instead, we are using a file system, Hadoop distributed file system. But databases means you are going to pull the data from database. How to pull the data, right? And directly in through PySpark can directly pull the data from databases. From where you are going to get the data means from the different databases. How PySpark directly it can take data from database. I'll be showing you, right? with the.
So
from a
it means
yeah.
like it can fetch the data from multiple databases like Oracle, MySQL, SQL Server.
It can see what it can do is from a particular database, it can bring data and creates one data frame. Another database, it will take the data from a table and creates one more data frame. Later, if you want to combine the data frames, we can combine all this.
Okay. Can you also like show us when like the database connection we put in a script, like if we are creating a Python script, then we have to write some Spark configuration and database or I mean connectivity configuration. So
Yes, sir.
where
Yes,
all we need to.
yes, I'll be showing you.
Okay.
Okay, so fine. Tomorrow you can attend the session, right? Tomorrow also you can attend the session, same time at 6:30 using the same link for tomorrow also. I'll be discussing about the fault tolerant model.
Do we
And
have a scoop class also tomorrow?
yes, those who are attending that Hadoop right, spoke class also will be there before this same.
5:30.
Yes.
Okay.
Okay. So I'm stopping for now. We'll continue tomorrow, right? Yes.